And so once again, I'd like to welcome you to the Common Core, What You Should Know, with our presenter, Hank Kepner. And he's the past president of NCTM, among many other things. This presentation is being sponsored by the Developmental Math Committee and AMATYC, which is what the Developmental Math Committee is part of. And this works towards one of our core values, which is to enhance personal growth of instructors. The views expressed by the presenter are not necessarily the views of AMATYC, and if commercial products are mentioned, they're not endorsed by AMATYC. This webinar is being provided by the Lift Institute at Muskegon Community College, who's providing the technological aspects of this today. And now I'm going to switch over to Hank. Slides, which are right. Oh, so I cannot hear Hank. 1 second. I'm going to stop myself.
Can you hear me? Hear me now? Hello?
Yes. Yep, we can hear you now. You're good. Oh, wait, 1 second, Hank. Something's gone bad with your sound. Can you click on the talk button on the bottom of the screen and just lock it down?
I'm holding the talk.
Yep, there you go. Just hit the lock button and it should stay down.
Okay, have we got it?
Yep, you've got it.
You got me. Okay. Welcome, everyone. Hank Kepner, past president of NCTM, and I'm going to try to give you a flavor of what's going on related to something called the Common Core state standards, in our case in mathematics. And that is something that has a little history. And I'd like to just give a little history, NCTM and AMATYC, in terms of this whole idea of standards. In 1980, NCTM had a little tiny booklet, about 20 pages, called Agenda for Action, that said the primary purpose of doing mathematics was problem solving. And that sort of started a whole set of things. In 1989, NCTM's Curriculum Evaluation Standards for School Mathematics, that document is the start of the national standards movement. Before any other discipline did it, it was a document done by NCTM talking to math teachers and the math community, saying these are things we value in mathematics. And it sort of caught hold. People read it and paid attention to it. Not long after that, working with NCTM, AMATYC took a look at that document and sent out its first look at talking about the kind of mathematics we expect for students. And that came out in 95. In 2000, NCTM basically revised and updated the curriculum and evaluation standards. So the 2000 document is a revisiting of the 89 document a decade later. Due to No Child Left Behind, NCTM in 2006 created something called the Curriculum Focal Points, which took the basic elementary expectations in mathematics and put them by grade level, because that was mandated by the Department of Education in terms of testing students at each grade level, 3 through 8, and then in at least once in high school. And in 2009, NCTM, our current focus is really trying to get at reasoning and sense making, particularly focusing on high school, because that's an area where often this hasn't gone as well as we had hoped as a council. And at the same time that's going on, AMATYC has been working on 2 projects, Quantway and Statway, as part of the developmental project. And I've had the fortune to not only be involved over this entire history with NCTM, but also working on some of the, in particular, the Quantway project and being aware of the Statway. So that's kind of a history in there. The Common Core State Standards Initiative was done by the National Governors Association. So that's the 50 governors, 50 plus governors, because of other state districts of Columbia and Guam and other areas. The governors and their corresponding chief state school officers, like the director of public education in your state, those 2 groups in spring 2009 commissioned the writing of Common Core state standards in mathematics and English language arts. And that was done for 2 basic reasons. It was a response to a lot of public criticism that states had created different assessments with different cutoff scores, and it was very hard to compare what was reported as student performance in a given state compared to performance in another state, where there were different assessments, different cutoff scores, and it really looked weird as the national assessment data came up, which was sampling across all 50 states. And the second motion was the idea of the business community impacting the governors, saying, wherever a kid is born and raised in this country, they are going to be moving into a world-class workforce, and we need to have a common education. So those two pressures caused the governors to say, we want to create Common Core standards, and the states would then agree to participate in that. And at this point, the math standards came out a little less than a year ago. 44 or more states and territories have signed on to those core standards. That means the governor and the chief state school officer said, we're going to go with those standards. And that's where we're at now. What that means, I argue, is going to be a long period of interpretation for all of us. So it's not that it's a done deal. The document is there. What does it mean? How do we deal with it? That's what I want to try to give you some opportunity to look at in there. So my first sort of polling question to you is, just so we can get a feel from the audience, what is your awareness or involvement in the standards in your state? In there. So if you can identify you're not aware of the Common Core at all, you're aware but not engaged, involved in some way, or directly involved, particularly from the point of view of being in post-secondary education. Okay, good. Gives me a little bit of help in there. The document which came out, it's been organized with three parts that are of particular importance to us. The key part, it's only about 3 pages long, are called the Standards for Mathematical Practice. And I want to come back to those in just a minute. The largest chunk of the document are standards for each of the grade levels K through 8, which said these are the main topics for instruction at each of those grade levels. And again, that's primarily in response to No Child Left Behind assessment regulations currently from the Department of Public Instruction and the federal Department of Education's work. And then at the high school level, the standards are listed by categories, general categories of content, not by grade level or by course. And I'll return to both of those in a minute. But those are the 3 components that are part of the document. Within that settings, the grade level, the domain, namely sort of a topic area, a big idea like number or fraction, knowledge and computation with fraction, things of that nature. And then under those domains, clusters of standards, which is really sort of like some bigger ideas with smaller bullet point standards, is sort of the organization of the document. For example, in the elementary sections, in each grade level, there's a narrative of about a page. And this is a quick little excerpt, tries to give an overview to the reader, and then identifies what are the critical areas. And then the standards are presented following that. The domain statement, a big idea, represent and solve problems involving addition and subtraction. Individual standards, and then they are clustered in that way. So that's what the K-8 component looks like, grade level by grade level, and within each grade level, several domains. Number and algebra, fractions, geometry, measurement, data and statistics, things of that nature. The Common Core gives us something from the state organization and their writing team, some aggressive timelines for teaching particular concepts in the elementary and middle grades. Aggressive in the sense it moves some grade topics to an earlier level of focus and work toward mastery. At the high school level, the content is there. It won't be too surprising. I'll talk about it a little later, but it was not produced to be done in any particular sequence, whether it's an integrated type curriculum or a more traditional curriculum in the United States. And it calls for the instruction of students recognizing and using mathematical reasoning, connections, and modeling as critical issues. And the standards for mathematical practice, these are critical ones that are identified and should be attached to all of the topical areas. So that's a critical piece to it. The first one, make sense of problems and persevere in solving them. That's a major goal. And secondly, reason abstractly and quantitatively. Construct viable arguments and critique the reasoning of others. I'll return to that one shortly. The critical thing to note as you look at the Common Core document, these are meant to be behaviors we can see in students. So it's not something you and I as the instructor do to students. It's a matter, can we get them doing those things as they learn and attempt to apply their mathematics? The remaining proficiencies and practice, model with mathematics, use appropriate tools strategically. Attend to precision, look for and make use of structure, and to look for and stress regularity in repeated reasoning. Each one of those has a major description in the document, but the total is a very short number, 3 to 4 pages at most. Those come from work that's been done over the last 2 decades, in part with NCTM's process standards, problem solving, reasoning, communication, connections, representations. Those 4 areas of student involvement with mathematics, not the content, using the content, but using it in specific ways. We have within the math ed community about 2 decades worth of conversations and interpretations of those. That's going to be critical to us in going forward in looking at and implementing this Common Core document. Another document heavily relied on by the Common Core writers is a document called Adding It Up from the National Research Council, which defined 5 student proficiencies in terms of being mathematically proficient. Not just procedural fluency, not just conceptual, but the idea of strategic competency, being able to formulate, represent problems, to adapt reasoning, to understand and know when to change your ideas. Say, wait a minute, this isn't working. And then the idea of productive disposition, motivation, habitual inclination to see math as sensible, useful, worthwhile, things of that nature. Those parts, the idea of the mathematical process standards, I just need to know where you are on those ideas. Are those things you're familiar with? Not at all familiar with? Things you attempt to put into your classroom teaching? Or is it a major part of your instruction? All right. Thank you. That's given me a good idea. One of the things that from this that I hope we can continue on is thinking about these apply to every piece of content you have. It can be applied to very typical topics, new topics, from kindergartners doing work they're doing with early edition work through the work we do. One of the reasons for that is a lot of the research on challenges with students in mathematics is that lack of student engagement in the mathematics classroom is one of our biggest problems. And the standards for mathematical practice, I see as our opportunity to say, can we really get the students engaged in that setting? The previous president, Governor Bush's National Mathematics Advisory Panel, they did a survey of over 1,000 Algebra 1 teachers across the country done by a national sampling process. And the most challenging problem reported by U.S. teachers of Algebra 1, think about, what do you think it's going to be? I'll give you just a couple seconds. What do they view the most challenging problem in teaching Algebra 1?
Maybe this would be a good point to ask our participants to, oh, you gave it away.
Oh, sorry, did you do it too quick?
Ask them to put it in the window.
Yeah. Okay, so the dilemma is, can we get them engaged and wanting to participate and identify that, gee, math really makes sense. I want to take one of those 8 standards and just parse it a little bit and say, here's some big ideas in there. The standard calls for constructing viable arguments and critique the reasoning of others, calls for several parts. One is understanding and using stated assumptions. And it would say, oh, what I'm saying builds on something prior. Now, we often think about that and our work with mathematics. Often the instruction maybe doesn't ask for that. When we're looking at procedures, we sometimes forget to help kids say, can I make sense of this procedure and do I expect it to come out this way. The second part, are they doing mathematical tasks that at times ask them to make conjectures? Is that always going to work? What do you think it is? And to start to build logical arguments. And the argument doesn't have to be a high-level argument. It might be done with manipulatives. It might be done with several examples and trying to build on those. So students at different levels, but they know they should be justifying or trying to justify something that they think might be true. And to work on that justification. And then maybe the most trickiest, and one we often don't do in the mathematics classroom, is getting students in the mode of listening to or reading the arguments of others, trying to understand them and ask questions, not to criticize them, but to make the arguments better, modify them in that process. So that's kind of what behind what we're talking about in terms of student behavior. Can we get students to do this with regard to the mathematics they're doing in there? The high school that I talked about, the standards from the national governors basically have the goal of the standards specify the mathematics students should study in order to be college and career ready. Now, my personal view is the document we have in front of it, it's really weak on the career readiness part. Most of the focus could be represented in sort of, quote, the college readiness side. The career part, I think all of us have some work to do to get students engaged. The major strands of mathematics looked at in the high school are listed here. You'd expect them in some ways. There's some surprises in there, at least in the way they're interpreted, that I want to go into in that setting. One of the things I think it's of value is, whereas we often talk about number as a key basis, the core talks about number and quantity, the idea that there's units attached. Most anything that's in context, there's not only the number, but the units related to it. And certainly in the high school setting and on into the post-secondary, often quantities have multiple units involved. A lot of the formulas from the sciences, the social studies, there's several different works. And how do we work on making sense of the quantity part, not just naked numbers or expressions that are algebraic, symbolic expressions, but with no context behind them. So it's calling for that to be a major area of consideration and discussion. The rest of number and quantity, not too much of a surprise. Complex numbers, there's just a touch on it for the core, in other words, for all students. Mainly seeing complex numbers as an extension of the system that allows us to solve things like quadratic equations. The additional work, where you see the plus signs, though the plus sign in the document refers to, that's additional work with complex numbers that students going beyond the Common Core would use. Students going into certain fields, obviously into certain mathematics, engineering areas will need that, but not all students. An area that they refer to, and I feel concerned that it's at this point in time classified as beyond the core, and that is work with vectors and matrix quantities. Those to me are very critical, particularly in the discrete areas, the social sciences and so on. That work comes up, but that's a part of the discussion to go on over the next good number of years as we look at our curriculum, both K-12 and into the post-secondary experiences. Algebra, there's some of the standard topics you would expect under the topic of algebra. The part that is maybe more intriguing is a very special note of the idea of function. And function really is the idea of interpreting expressions, interpreting things that are in context, and writing the expressions that describe a contextual thing from the sciences, social sciences, business world, and then putting it in algebraic form. So building functions, which then lead us to some of the algebraic work, the use of that for algebraic work in that part. Certainly looking at linear, quadratic, and exponential models as the most prevalent ones all students should experience. Trig, again, there's a little bit of trig presented as one of the extra models, but not going in depth for the core. The core parts are pretty much the introductions to modeling periodic phenomenon, temperatures across the temperate zones, tidal waves, things of that nature, and a lot of other things of that type. Modeling is called for, and this is part of going back to the mathematical practices. Students get extended experiences in model building and interpretations. And it calls for doing this throughout the areas, in the algebra, the function, quantity and number, geometry, and certainly in the statistics and data areas. But this is seen as opportunities to model from contexts throughout their coursework. This part, I think, corresponds very well with the work going on in Quant Way and Stat Way from AMATYC, two projects going on under the developmental math committee work. All right, that gives me a plea. For those of you who have not seen those, I think that they're worth looking at. We'll have them identified and you can follow the work that's coming out. Both of those, Quant Way and Stat Way, are in pilot versions now, and I think will be used this coming year in several institutions, looking at that as a way to get students engaged in the mathematics required of them. The work is pretty much done at the level of getting students prepared to enter their first credit-bearing courses at institutions of higher education. One of the things asked, there's quite a bit in our field within the National Council of Teachers Mathematics and work we do. One of the questions asking about teacher preparation. And students in the preparation of teachers should be getting some experience with statistics and probability, with the emphasis on the statistics or data analysis, not heavy into the probability formulas, things of that, permutations and combinations, but more into analyzing data and learning how to do some of that. And I'll come back and mention that. But that is expected in our teacher ed programs. And it's certainly part often of many of the state expectations in terms of if there are exams teachers take to show they're prepared. And most universities within their teacher preparation courses and the content courses for teachers have chunks of that. Now, not anywhere near as much of the stat and probability as we would hope, but it is moving in that way. Yeah, in many cases, and I think we're moving fast, that 2-semester course in elementary teachers, mathematics for elementary teachers, does include that, and I would certainly hope it's not being skipped, although sometimes it gets less emphasis perhaps within the process. All right. In the geometry, I want to mention the critical side. Most of the topics in geometry identified for the high school level are not unexpected, except the focus is very different. One of the things the Common Core standards call for, both starting in the middle grades but in the high school, is a lot of the work being done through transformations. So rigid motions in the plane, the flip, slide, turn, as tools to do a lot of the work that historically many of us saw as a passive view of Euclid's elements. So actually picking up a figure and setting it down on top of another one to see if they fit. That becomes a definition of congruence. Similarity becomes, you take the idea of a congruence, get it organized right, and then scale it, dilation up or down, to see if it fits on top of the original object. So a real way of looking at geometry as an action activity, not as a passive one. And that's partly done, I think, in part that almost everything our students do, they see that kind of geometry going on, and all of their video games, everything on their iPods, their various game boxes are transformational geometry as the tools behind what is happening in a motion sense rather than a more traditional passive sense of collecting information. In the area of statistics and probability, notice it says statistics and probability. In my era, it was often talked about probability and statistics. And the focus is getting students using and figuring out what to do, how to collect, categorize, and represent data. And building later, as you build the inference part, the probability side comes in a little heavier. But getting a lot of work early with statistical data and information. Working with my colleagues in the social sciences and certainly in the health sciences, that's about all they do is data collection, data analysis. So that's probably almost their most critical area of mathematics. It is used throughout students' careers. I know on our campus, almost every major has stat requirements and stat usage in it, except the languages and a couple of the fine arts. But almost every other field uses that, and often it's used without adequate student background. As I indicated, when you get to coming back later and maybe justifying and building some of the foundations after the seeing of the use of data analysis to come up with the probability relationships in there. The Common Core document has an appendix, which isn't a required appendix. It's called Appendix A, and it provides information at state's request about how might you organize the Common Core curriculum over 3 or 4 years in a high school program. And through a lot of discussion in building this, they did not come up with one way to say to do it. There's one example, some examples given, which I'll refer to as the U.S. Common Curriculum. That means the idea of, in high school, algebra, geometry, and algebra 2 in some order. That's a particular sequence used, to the best of my knowledge, only in the United States. No other country in the world uses that. In fact, the work we've done on some of the international studies, we cannot find a course like Algebra 2 in most countries. There isn't anything even close to what we do. However, it's well embedded in our curriculum. So they're suggesting ways that the topics I just mentioned go together, but not necessarily in that order. Also, they identify, because when they were asked to look at comparing us internationally, there are a good number of integrated curriculums out there used in the United States, becoming a little more popular in schools now, is the International Baccalaureate exam. Many states have that and used in a good number of schools, particularly often schools of kind of like math, science, specialty schools, things of that nature. And there are other international models out there, but they differ quite a bit in terms of the sequencing or what topics they put together. And then there's several U.S. models, particularly some of the integrated math curriculum that was supported as introductory exploratory projects in the integrated math at the high school level. They're very different. They're looking at it. I would encourage you to look at an article that it's on the NCTM website from my president, Mike Shaughnessy, talking about the time to look at integrated mathematics as an important part. The focus here is they can be clustered in different ways, but that each year there will be some exposure to mathematics that comes out of the algebra functions area, out of the geometry area, and out of the data area, rather than compartmentalization in the process. That will be a continued discussion for the rest of our careers, I guarantee you, in there. The pathway, which somebody does, is not as important to me as, is it really well done? Is there a focus? Is there coherence? And in particular, are there connections across the standards and the topics that a student experiences? I'm very worried people will just cut and paste topics together, but without good tasks, good expectations, and good questioning on the teacher's part to connect the algebra, the functions, geometry, data in significant ways, so the students see that they really are all part of mathematics in there. I want to switch to a side we're moving into now, and this is maybe the biggest one for all of us, and that's the area of assessment. And I say elephants in the room, not just elephant, because there's several levels of assessments going on. At one level, we have, from No Child Left Behind, the idea of a high-stakes accountability. In the case of mathematics, grades 3 to 8 in every state, and at least once in the high school. And that's an area that, until No Child Left Behind is reauthorized, which we've talked about it for a long time, but it never gets high enough on the agenda in Congress, we'll have that accountability. And a current issue, as you've watched nationwide from state to state, it's not only the idea of measuring students' performance and then talking about measuring schools that have a high number of students that are proficient versus a low number. But it's becoming a major one, particularly in the state of Wisconsin and the state of Ohio. If you watched us on TV a lot, the idea of ranking teachers. So that accountability is really becoming a big issue in there. And secondly, and this is coming out of the Common Core work, which I'll get to in just a second, the next step, is using Common Core assessments for admission and placement to your institution. And that's one I want you to, sort of be aware of. We'll come right back to that in a second. Let me get these up here. The Department of Education funded 2 large assessment consortia. When I say assessment consortia, these are consortia of states that said, okay, we're going to get together and get some help building good assessments that we can use maybe commonly across our states. There are 2 of them. It was asked earlier, what's PARC and what's SBAC? These are the names of the 2 big state consortia. PARC, which includes Achieve. Many of you may come from states where the Achieve project was very much looking at the high school standards over the last 4 or 5 years. That's a consortium of between 25 and 30 states that are sort of working together trying to create assessments. And there's another set of about 30 states that have joined together under another competing funding group, assessment consortium, called a Smarter Balanced Assessment Consortium. Now notice the numbers I said didn't add up right, because some states are haven't made up their mind yet, and they're sort of watching both. So the 2 groups have about equal number of states that say, can we get together and build assessment tools together, share in the efforts and share in the reporting? Because one thing that the governors would like to see is some common reporting across states by grade level and by high school level, things of that nature. Here's an example, and this is what PARC shows as their process. I'm taking this certainly from one of their documents, but it's similar for the Smarter, Better, Balanced part. Doing informal assessments in K2 in the early childhood grade levels and so on. Very specific, the ones that are required under No Child Left Behind, grade level tracking of students' performance in grades 3 to 8, and then some performance at high school. But as I indicate, these assessment consortia are aggressively looking at saying, we think you should be using these assessments as part of your admission and placement process. So they're actually coming to higher ed saying, we would like you to use our assessments. So that's one that'll be a clear area of importance for you to be aware of and to monitor in that process. For example, PARC claims in the 25 to 30 states it's working with, that they're really going to post-secondary institutions and systems to get their help. They claim 200 post-secondary systems and institutions representing nearly 1,000 campuses are being recruited to be partners in this process, where the high school Common Core assessments might be used for your admission and placement decisions. And so my question is, are you aware that this is going on around you? Let's see, is this? Oh, here it comes.
If I can just clarify, we're answering this question as it relates to our institution's involvement with assessment related to these standards. Is that right?
Yeah, coming from these assessment consortia, right? All right. Now, over about half the group claims your institution is not involved, and a third of the group says you don't know. I would argue both of you may be in the same situation, because one of the things that's happening, this consortium approach, in particular this is Achieve working with PARC, they have aggressively approached the post-secondary institutions. When they come to a specific department, they often get a pretty cold shoulder. So they're going around the departments. They're trying to go to your state system and get your president of the state system or the governor to say, we're going to do it. So in saying this, I'm saying, you better be sure, you and your colleagues should say, are we really being asked or brought into this with or without our knowledge. And I don't say that in a negative way, but to say you better be involved, because we want to know, as these high school tests get created, are they useful to you? It's going to be really bad if you're, in a sense, forced to use them for decision making and they turn out to be not very helpful. So over the next few years, as these tests become available and used by all of your students in the high school level, you are going to be under a lot of pressure to participate and use them to cut down on the amount of separate testing and so on. Each state's going to make that decision separately. So it's not that the whole country is, but there's a lot of pressure to get commonality in the assessment process as well as in the common standards process. Let me just cover a couple of things here. Here's a whole bunch of challenges. One, students are going to be tested at least every year in grades 3 through 8 and on into high school. And the goals from the assessment consortiums, they're actually going to be able to have a tracking a student's growth over time. That's a great goal. It can be very helpful to us as educators, as teachers of those students over time. We have a lot to learn about, is the data really going to give us that kind of growth information about the student? So even if there's tests given, how useful, we all have to learn, both how to use it and does it provide things that are important to us and useful to us in the teaching. What I mentioned is a lot of this testing every year thing relies on the federal congressional reauthorization of the Elementary Secondary Education Act, of which Secretary of Education Duncan realizes that there's a lot of things that need to be revisited, tweaked, and changed in that act. In fact, he even speaks to the point of maybe testing every year is overkill. But so far, nobody's got pen to paper to really do significant changes in it. And as a result, year after year, we're sitting with the same requirements in there. What's going to happen to states who signed on, but they didn't get race to the top money? Because it was a major pressure from the Secretary of Education that if you're going to get race to top money, that extra stimulus kind of money that came along, your consortium, your state said, we're going to sign on to be part of this testing package. And a bigger question, this whole Common Core standards movement, where does it go and how will it impact us, is very interesting. It was started in 2009 by 50 governors and their state education leaders. As of today, 29 of those 50 governors are gone. It's not clear their successors are going to be as interested or as involved or as passionate about some of these original goals. So to you, a point in this very volatile educational political arena, where are the governors and where are the leaders in your state, in the sense, are you going to stay to these, increase their use, or make modifications? Challenges that I want to just point out. The Common Core, particularly in grades K to 8, it gives us a lockstep curriculum, apparently, for all students, as these are the big ideas at each grade level. That's good news in one sense, but there's a couple of problems. What does it do to high-performing kids, kids who should be maybe taking on bigger challenges? If the focus is on accountability testing, and these are the things kids should know, I'm concerned that high-performing students may not be challenged to mathematics beyond what's called for at that grade level. That's a serious concern with the pressure and accountability behind some of this work. The second part is all our research on kids learning. Kids don't learn it at just one time and get it all locked in at the end of one grade level. So I'm very worried student growth takes a long time. One example, clearly, we've got a lot of research on building people's proportional reasoning. That can take several years, and it's squeezed into a tight place in the Common Core. What are we going to do with students who don't have it quite at that age level? There's going to be serious educational questions for all of us in there. Just challenges over time. Practices, those student behaviors I mentioned, they are isolated. We've got to make sure we attach them to every standard and the activities that we do in the instruction of mathematics in there. although it talks about modeling, it doesn't give us a lot of help. And the document encourages the use of technology, but it's very bland on really calling for technology use to really make sense of the mathematics. Give you an example. One of the things is I work with people, particularly in the social sciences, so for students going in that direction, the tool they use the most is not the graphing calculator, which we often may think of as one of our tools. They want kids who are totally competent with spreadsheets, because what they do with data is almost totally spreadsheet based. And then secondly, the call for mathematical connections across the mathematical strands in there. Your job, pay attention, keep in touch. And then now I want to open to some questions and continue some work. I hope I got several of the comments along the way, but now we'll open to some more questions. Maria, you?
Yep, so participants can go ahead and type their questions in the chat window or raise their hand and we'll attempt to grab your mic, although I don't guarantee it will work 100% of the time. I have just a general question I'll ask. What do you think is the most important thing we do with regards to this Common Core? You know, most of us are community college instructors. Where do you think we have the most impact and the most influence over this process?
I see it two parts. One, I really encourage your community to really work hard with our high school community as we relook at our high school curriculum in mathematics, and to make sure we do as best we can to get them connected, because often, certainly to students, they look very disconnected. And so I would hope if you have the opportunity in your state or in your region, for example, with a community college, with some of the school districts in your area who might be looking at this, or the state agency, help identify connections, the translations from one to the other, talking in collaboration, not one group trying to, badger the other one. And in particular help I think we need from you is helping us find good tasks, good applications that will engage students, and yet they're pertinent ones for you to use when you get students on your campus going into a range of fields. The high school math curriculum often we haven't done a good job of getting tasks that really make sense across the various certifications and so on you have in your programs. But then on the assessment side, I say, get in there in the point, because we're going to need your help to say, whatever these assessments are given at the high school, are they helpful to you for admission and placement part? Admission may be one issue. How these assessments will compare with ACT, for example, states that use ACT. I don't know how that battle will come out. ACT may not want to give up their income in this process. So that could be a discussion point for many states. For example, the state of Illinois, of which I think the ACT test is now their No Child Left Behind test at the high school level. Where does that fit? How useful is that for you in admission and placement? A particular question on that assessment is, in our work, students are likely to be taking this test at the high school level, I would think, in their junior year. And that's productive. It tells you something. It tells the students. I'm not sure if you're going to take placement, which might come a year to 2 years later, based on something that was done that much earlier. So I think it's going to be a hard challenge for us to say we're going to take that as the measure in terms of your best job to place the student in a class where they can be successful as they come onto your campus.
I think a good question that Laura, or a good point that Laura brings up that maybe you could talk about for a second. When we look at the Common Core standards, and they're kind of a broad swath of mathematics, in the dev math areas we have currently in many colleges, we have a very narrow focus on algebra.
Right.
Do you think that we're going to hit a critical time period here? I guess maybe the question would be, when will we hit a critical time period where we need to align better to what the high schools are doing? At what point will these students start to reach us?
Well, I think some are starting to reach you now, not a lot, but I guess the question for all of us is, can we really make the rest of mathematics seem like it's worth doing? it's certainly my experience in teaching high school algebra, that a lot of kids, when it's been rather focused and narrow, they don't see any purpose in it. And I think one of the challenges, both from the practices, the idea of behaviors, of modeling and so on, but also the other parts of mathematics, they all go together. And the algebra is a set of skills, very powerful skills, but doing them in isolation is not very productive to students. For one thing, I know from my experiences here with the technical colleges in Milwaukee and our non-credit bearing courses at the university, students who take these rather isolated algebra courses as we traditionally have them, I think they forget most of what they did in that within a semester. And so it's a scary part. It doesn't stick unless we can make it connect to something that they see as more valuable, more purposeful. And we're going to need your help to help us come up with good examples, ones that can carry through to say, well, that's why I need that algebra, and continue to work on the algebra in the midst of doing the other work, whether it's out of data analysis, whether it's out of the geometric transformations, and things of that nature. I agree. One of the other comments that came up. Yeah,
Steve has a question at the very bottom there.
Oh.
He says, any chance that the Common Core standards are going to shift or alter much in the near term?
I think they're going to shift things in the sense of that the expectation is that all students in high school are going to have at least a pretty good chunk of statistics and probability experiences. And my hope is, and the applications for why you do that stuff. I know most states, they're scrambling in, let's say, this quote, Algebra 1, Geometry, Algebra 2 sequence. How do they get the stat in there? And there's books that are working with it, there's curriculums working at it, but that's a big side. I would argue we have a good shot at doing that in the sense of a lot of the algebra in Algebra 1 can be done with data stuff and say, how can we best describe the data? Whether it's a line of best fit or other ways of learning how to make graphs of scatter plots, things of that nature, which really create the need for the algebra skills. And I see that as one of the key places where that's probably happening. The other part, I think it makes us revisit what are the depth of skills, for example, in the Algebra 2, things leading to the college algebra, the pre-calc course, that students who are not going to go on to take a calc course should be involved in. There's work in discrete mathematics, for example, I mentioned that particularly the area around matrices and so on, that are probably more important than a lot of some of the more subtle pre-calc skills we use for students who don't go that direction. The question I see there from Mathashi, the idea, I'm calling for your community to work with the high schools, and I encourage you to make that contact, as I would hope we will be from secondary education, making the contact to work with you, so the things we're building there do connect, and you realize how we're going to connect to the curriculum you have. And in some cases, it means both of us are going to be modifying some of our curricula. I think the Quant way and the Stat way are some good examples from your community. They're saying, these are starting points to make this happen. And in particular, these are starting points for kids who are not likely to be very excited or in the past very productive in mathematics.
I better start wrapping up here and thank Hank for his time today. We will put these the video and the slides up on the website as shared previously. Just a couple of notes before we go. I need to switch back here so you can see the link to the evaluation for this webinar. Sure. So just a reminder for those of you who aren't AMATYC members that AMATYC is the one sponsoring all of these. So if you'd like to support that, you're always welcome to become a member of AMATYC, and we have membership at both full-time and adjunct levels. And if you'll just copy this link into a browser window and take 2 minutes at the end to do an evaluation for this webinar, I'll just go ahead and type it in here. And maybe we can all give Hank a hand for his presentation. There's a little applause button you can use at the bottom of the screen. So that you can give him.
And if I can add, Maria, certainly individual things that you've raised I haven't got to, my email was on there, send me an email, and I hope we can keep these conversations going, because to me, this Common Core, the assessments that go with it, this is a decade of conversation for all of us. It's not one document and a done deal. We need to learn what it means talking to each other. And I hope to be able to continue to encourage and facilitate that kind of discussion.
I've just